let's take a look at these, buddies. So what I got going on is we got two freezers that are down, two reach-in freezers. Interesting enough, they're both off of one breaker. So it really could be one system is actually tripping the breaker for both of them, making them both go down. So what I got to do is I got to basically look at both of these, find out what is actually wrong, what's tripping that breaker. A lot of times it's going to be a compressor, which is just surging too much or something like that. So I'm going to take a look at it right now. Now you see when we take a look underneath, take a look for that wicking kit. We got a compressor on both sides. This is a dual compressor system. And so we have to check both compressors, see which one's amping out. And we'll do that with both systems when we can. So what I'm taking a look at here is I'm going to find out what's really wrong with the electrical system, but I need to take a look at what the electrical system has. So if you look in here, this is going to be your grid. Now, right behind here, you'll have your controller. So this is your controller here. Power is going to come in here, and it's 208, 230. So we're going to have two hot lines. So this is one hot line, and this is our second hot line right here. This line is going to go directly to the compressors to feed them, and this is going to go into your control system. And so what we're going to want to do is we're going to want to find out any kind of amp draw that's going to those different compressors to see if we're getting anything that's overamping. So we're going to measure this red line and this black line and just find out what type of power we got coming through here and see if this is the one that's actually amping this out. Because we have two systems hooked up to the same breaker, what I'm going to do is I'm actually going to turn the breaker on, then I'm going to shut both systems off. When I shut both systems off, then what I can do is I can bring each one up individually and find out which one's actually the one that's tripping the breaker out. So first thing we do is we're going to turn the trip breaker off. We're going to turn it back on. And we're going to come back out here. We're going to turn both of these off. So go ahead, turn this one off completely. So we know it's not going to be tripping anything. And this one here, we want to turn off completely for now, because we're going to bring it on in a controlled fashion. Both compressors are working fine on this side, but we're gonna still want to run it and see if it drops down in temperature and things like that. And then there are a few things we're gonna want to do. We can actually clean this up, clean up some of this electric. Definitely want to replace the wicking kits here. And then on this side, again, just clean it up a little. I'm gonna kind of show you this. I measured the temperature that's just in this box and see how we saw that 65 degrees. And then if you actually look, you'll see that fan right there. I went ahead and measured the temperature in that fan. We were getting about 60 degrees going in there. And you look here, we're getting 28 degrees coming out the back side of that coil. If you follow that line up, you'll see that I went in the back. That's where the cool air comes from. I'm not gonna open up and look in here because we have these door switches. Every time I open it up, it turns everything off. So I wanna leave it running. So I want to see how far down we can actually get temperature to cover. And right now it's just a little bit of a waiting game. So just have some patience and we'll watch the box come down in temperature. And during that time, I'm going to go ahead and I'm going to clean everything up a little bit. And I'm going to replace some of the wicking kits and just do some of the stuff right there that just really makes this system run way more efficient. Our temperature now coming out the back end is down to 17 degrees, so we know it's dropping really good. You'll see I brought in some stuff I brought some nitrogen, which kind of helps me blow out the coils. Vacuum cleaner helps me vacuum everything down. Some stuff to wipe everything down with. Also, my box of goodies there just has all the extra parts that a system like this is going to need. Boo! So we're having some pretty good operation with this unit. So probably once we get everything down, we'll be able to close it out, and it'll be a good unit. Probably the problem is going to be with the next unit. We'll know that here shortly. For the second one, I went ahead and I'm going to turn this first one off, and then we're just going to work on the second one. So what I'm going to do is I'm going to have to actually isolate it, and just like I did on the first one, I'm going to have to isolate each one of the compressors and just find out which one of these compressors is acting up and what's kind of drawing the system out. Now, it could not be a compressor either, so we're just going to find out what's going on. 14 amps is a little high, but depending on the type of system, if that's going to be too high. Have to take a look at that and see what else we got going on. You take a look at these new R290 compressors. Sometimes there's an issue with how many amps they draw to actually run the system. So what I'm doing right now is I'm calling True because I can get a warranty work on them. What'll happen is I can actually get them to warranty send us a new starter kit that has a larger capacitor on it that will get this compressor running. So what'll happen is sometimes these compressors just take too many amps to draw, and it'll actually trip breakers, especially if they're running two systems on one breaker. So what we're going to do is we're going to get True on the phone, and we're going to be able to get a warranty replacement for this start kit. After calling True, finding out that the system was actually amping up to about 80 amps, we realized that we couldn't just add a new kit. We're going to have to actually replace the entire compressor set. But before you can replace it, True actually wants to ensure that the unit is on its own dedicated circuit. So we have to actually talk with the store and get them to put this thing on its own dedicated circuit prior to any type of warranty replacement. So that is where we are right now. We're actually going to have to call it in, get a get an electrician come in here, do a dedicated circuit, and then do a warranty replacement of the compressor. So that was a fun little job. So we actually showed up and we had 2 calls at one location, but they were both for freezers down. Now, both calls came because one unit actually tripped the breaker. Both units were hooked into one breaker, which they're supposed to each have their own breaker. And now you see why, right? Because one went down, killed 2 systems. The first system, we took a look at it. It was actually fine. The only issue that we really had with it is that it needed, a new wicking kit and just needed to be cleaned up a little bit. So we got that running, looking perfect. And then when we went to look at the second unit, we found that it has 2 compressors, primary compressor and kind of like a secondary compressor. That first compressor picked up, ran just fine, no problems. That second compressor, when it first started running, it was running about 14 amps, which is a little high compared to the other ones running at 4 amps. And so, that's a little bit of cause for concern. But what really was the cause for concern was that when it started running and it would amp up to about 80 amps and then tripped out the breaker. So we realized it was that secondary compressor. Now, when we called True, it's under warranty, so it'd be replaced under warranty, but they will not replace it until they know that it has each unit's on its own circuit. It has to be on an independent circuit. Once they verify it's on an independent circuit, then they're going to send out the compressor for replacement. Now, it's an R290 system, so that's a propane refrigerant. And so that means there's some special controls for when you're replacing that. So you can actually just release the gas to atmosphere because it's propane, and so therefore it's not considered a greenhouse depleting gas. So you can release that to atmosphere, but then you got an issue with the fact that it's a very highly flammable refrigerant. So you release it, you got to control the space, get a fan, get all that out of there before you can actually go in and start brazing in a new system, and then putting in the, because that's an open flame with flammable refrigerant. So we actually get that all out of there, get the system clean, put the new system in. So that's going to be something for later. We're not going to do that right now. So we have to get the new electrical line in, and then get the warranty processed and the part sent to us, and then we'll come back and replace that part.
Make sure you subscribe, and you can see all of our videos on, I don't know, YouTube.